In today's video, we'll be looking at the derivative of a function just to differentiate a function. Now, all of these are the standard derivatives. The standard derivative means when you have a function and if you differentiate the function, your result is a derivative of that particular function. So that's what we mean by also all of these are standard derivatives. So if you differentiate an algebraic function, this is what you're going to get. Differentiate an exponential function, you get this. You differentiate, all of these are for trigonometric function, these are the results, and then a ln, which is a logarithmic function, you get 1 over x. So therefore, now let's assume we have y equals 3x raised to the power 7 minus 12x 5 plus 3x2 minus 1. Now I want to find dy dx. Now to find dy dx means I want to get the first derivative. So now I'm going to differentiate y with respect to x to get the derivative, which is dy dx. Now what I'm going to do, because this is an algebraic function, if you look at the form, okay, let me start with that. If you have ax raised to the power n, what it means if you to get the y dx, it means you're differentiating y with respect to x. You're going to multiply the power of this algebraic form by the coefficient of x, then you subtract 1 from the power. If you do that, your result will be a multiplied by the power is n, then x raised to the power n minus 1. So dy dx will give me a n x raised to the power n minus 1. So this is the derivative. I can get the second derivative of this function. If I want to get the second derivative, it means I'm going to differentiate this function the second time. So I'm going to do d squared y over dx squared. Should I do that? The power is n minus 1, so I'm going to multiply the power by the coefficient is an. Now I'm going to do an dot n minus 1 dot x raised to the power n minus 1. I'll subtract 1 from it. So therefore my results will be a into an into bracket n minus 1 x raised to the power n minus 2. So now this will be this is the result of my second derivative. So my second derivative will be this. So this will be the result of my second derivative, d squared y over dx squared. So this will be the result of my second derivative. Now let's solve this problem on the board. I want to get the first derivative is this is an algebraic function. Now you can see that this is a constant. The derivative of the constant is 0. I'm going to tell you why. Because this simply means x raised to the power 0. Because x raised to the power 0 will give me 1. 1 times 1 will give me 1. And 1 times minus 1 will give me minus 1. Now I want to find dy dx. Now I'm going to multiply the power by the coefficient. I'll get 21x. I'll subtract 1 from the power, get 6. I'll do the same thing here. Multiply the power by the coefficient. The coefficient is minus 12. Minus 12 times 5 will give me minus 60x raised to the power 4. I'll subtract 1 from the power. I'll do the same thing here. 2 multiplied by 3 will give me plus 6. Then I'll subtract 1 from the power. I'm going to get just single x. So this is minus 1 multiplied by 0. So minus 1 multiplied by 0 will give me 0. X raised to the power 0 minus 1. So all of this will still give me, all of this will give me 0. So therefore, the y dx will be 21x raised to the power 6 minus 60x raised to the power 4 plus 6x. Now I can find the second derivative of this. Now I've gotten the first derivative. It means that I have to differentiate this the second time. So if I want to do that, d squared y over dx squared equal, So I'm going to multiply the same thing, this times this. So I'm going to get, this is 6, 126x squared minus x5. So I'll come here, this multiplied by this, 240x3, then plus 6. The reason is because I multiply, the power of this is 1. 1 times 6 is 6. 1 minus 1 is 0. X raised to the power 0 is 1. 1 times 6 is 6. So this is my second derivative. Now this is an algebraic function. Now this will take us to function of a function. This will take us to function of a function.